Welcome back to another training video using the UK electrical simulator. In this video we're going to look at the different types of equipment that can be supplied from a fused spur and show why the standard 13 amp fuse is often replaced with a smaller 3 amp fuse depending on the load. On the workspace we already have the extended kitchen ring from the previous video. We already know how to wire a fused spur from an existing ring final socket. So to save time, I've already added and wired 4 fused spurs. I've also placed 4 current clamps on the supply conductors so we can clearly see the current drawn by each arrangement. Let's start with a small water heater. From the components list, add a water heater to the workspace, then double-click it and select Model 1, which is the 1.5 kilowatt version. Higher powered water heaters would normally require their own dedicated radial circuit, and we'll look at those in a later video. But for this fused spur example, the lower powered model is suitable. Now connect the line, neutral, and earth from the fused spur to the water heater and energize C2. There is a small on-off button on the water heater itself. Once it is switched on, we can see from the clamp meter that it is drawing 6.52 amps. That is well above 3 amps. And also above 5 amps, so in this case a 13 amp fuse in the fused spur is the correct choice. Now let's isolate the circuit and move on to the next example, this time a set of 12 volt garden lights. First, add a transformer set to a 12 volt output. This converts 230 volt AC to 12 volt DC. If needed, the transformer can also be changed to 9 volts or 5 volts by double-clicking the component and selecting a different setting. Next, add a one-way switch and then add 10 DC lamps. Connect the line and neutral from the output of the fused spur to the input of the transformer and connect the CPC to the relevant earth terminals, including the switch position. Then connect from the positive output terminal of the transformer to the COM terminal of the switch, and from L1 on the switch to the positive terminal of the first DC lamp. Then extend that positive conductor so that all lamps are connected in parallel. Now double-click the switch and add a back box connector. Connect the negative terminal of the transformer to the back box connector, and then onto the negative terminal of the first DC lamp, again extending it through to the remaining lamps. In this example, the 12 volt DC garden lights themselves do not require earthing. Once all lamps are wired in parallel, energize C2, switch on the fused spur, and then switch on the one-way light switch. We can now see from the clamp meter that the current draw is only 0.13 amps. That is a very small load, so the standard 13 amp fuse fitted in the fused spur would be far too large. In this case, it would be much more appropriate to replace it with a 3 amp fuse. Now let's move on to the next arrangement, this time using a couple of 230 volt AC outdoor lights. First, isolate C2, then add a one-way switch and 2 outdoor lights. We've already wired several lighting circuits in earlier videos, so I'll wire this one quickly and then check the current draw. With the circuit energized, we can see the current draw on the clamp meter. Even with 2 standard outdoor lights connected, the load is still low enough that a 3 amp fuse is the sensible choice. Now let's increase the lamp rating and change both lights to 200 watts each. We can now see that the current has increased to 1.74 amps, which is still comfortably below 3 amps. So even with 2 200 watt outdoor lights, a 3 amp fuse is still suitable. Now let's isolate C2 once again and move on to the final fused spur example. this time a gas boiler. A gas boiler uses electricity mainly for its electronic display and controls, plus the water pump, so the electrical load is usually quite small. I'll quickly wire that circuit now so we can energise it and check the current draw. Once powered, we can see that the boiler is drawing only 0.65 amps. So once again, a 3 amp fuse is the correct choice here. So, to summarise what we found, for 3 of the 4 examples, the standard 13 amp fuse supplied with the fused spur was too large, and a 3 amp fuse was the more suitable choice. Only the small water heater, drawing 6.52 amps, required the fused spur to remain fitted with a 13 amp fuse. I hope you've enjoyed this video showing several different types of equipment that can be connected to a fused spur and how to decide which fuse rating is the most appropriate for each one. Please like, subscribe and leave a comment below.